N-type semiconductor. So there are two types of semiconductor. One is intrinsic and another is extrinsic. So between in two types of semiconductor, N-type semiconductor is in extrinsic semiconductor types. So what is actually extrinsic semiconductor? If we add some impure material to a pure semiconductor, then it is going to be an extrinsic semiconductor. So there are two types of also extrinsic semiconductor. First one is p-type and the second one is our n-type. So what is actually the n-type semiconductor? When we add some impure material which is in pentavalent atom, to a pure semiconductor, this is called our n-type semiconductor. So if we cross section the n-type semiconductor, we get only two types of thing. First one is our pure semiconductor, which is 100% pure, and there are some example of our pure semiconductor, like about silicon, germanium, and so on. And also when we add this pure semiconductor to a pentavalent impure atom, which is very lower amount, then this is called our n-type semiconductor. So in n-type semiconductor, we have two types of thing. One is pure semiconductor, another is pentavalent impure atom. So there are two types of characteristics of this pentavalent impure atom. We add very low amount of pentavalent atom. Okay, so what is actually the pentavalent atom? The electron of pentavalent atom, the outer shell of electrons of pentavalent atom are only 5. So if you find an atom which have only 5 electron on its valence shell or outermost shell, this is called our pentavalent impure atom. So the example of our pentavalent atom is antimony or arsenic and so on. If you see on the periodic table, then you find 5 or 6 these types of pentavalent impure atom. So this pentavalent impure atom, the amount of pentavalent impure atom is very much low. If you consider, if we consider the 10 million, okay, I write there 10 million, okay, 10 million. So if you apply 10 million pure semiconductor and attach this 10 million pure semiconductor to 1 to 10 atom of pentavalent, then this is called as n-type semiconductor. So there is a very lowest amount of pentavalent impure atom is added to a pure semiconductor, then it forms the n-type semiconductor. So here is the structure of n-type semiconductor. You see there are lots of silicon, they are combining to each other by using covalent bond. So if you see, there are two silicon semiconductor which can easily mix a covalent bond and a covalent bond, and this covalent bond contains only 2 electrons. So each of the silicon makes 4 covalent bond to each other. But here is the problem. What is the problem? I just take or pick a little amount of antimony, which is a pentavalent impure atom. So this antimony, I set it inside the silicon lattice. So what will happen? I know the we know that the antimony have only 5 electrons on its outermost shell, which is our valence electron. So in this valence electron, only 4 electron can easily combine to the another silicon semiconductor around it. Okay, so antimony have 4 electrons. Suppose these are 5 electrons. This is 1 electron, this is our another electron, this is our another electron, this is our another electron. But another extra electron, this extra electron cannot combine to any silicon atom, because silicon only have the 4 hands or 4 valence electron. So this 4 valence electron cannot attach the another new antimony electron. So that's why this electron stay there, and also this is one kind of free electron. So we know about this electron, this is the 5th electron, and this is coming from this antimony atom. So this free electron cannot make any covalent bond or cannot share its electron to another silicon atom. So in that time, in n-type semiconductor, extra free electron we have created. Okay, so we get it. So this free electron can easily passing from one atom to the another atom, and also it increases the conductivity level of this semiconductor. So when we consider about the pure silicon semiconductor, there is no free electron. But in that case, when we apply the antimony and attach this inside the silicon lattice, then it creates one free electron, and this free electron can easily passes from one atom to the another atom, so it increases the conductivity level. So we know there, if we draw the another electron, then it is looking like this, it looks like this. So here are the various types of electron, a vast amount of electron, but all the electron are fixed, but there is an extra electron that we get. Okay, but when we apply the pentavalent impure atom, we do not apply, or we do not what I say supply only one antimony or one arsenic. We supply more than one atom, which is 1 to 10 atom or so on. Okay, so in that cases the free number of free electron is increased, and this free electron helps the silicon semiconductor to conduct the current. So there are two charge carrier. So if I want to share about the idea of charge carrier, so this is two types. What is charge carrier? Charge carrier is actually one kind of phenomenon of semiconductor which creates the opportunity of flowing the current. So charge carrier helps the semiconductor to flow the current or flow the electron. So in this semiconductor we get only two types of charge carrier. The first one is our electron. So here you see whole types of very vast amount of electrons. So first one is our electron. But what is the second type? Second type is our hole, because hole and electron are the two charge carrier of semiconductor. But here we do not see where is the hole, but when we see the electron is moving from one side to the another side, and when the electron is passes from one side to the another side, there is a vacancy of electron. I want to show there, because there is a electron. Suppose this is the electron, and there is there is a long path of the flowing of electron. But when this electron is jump to this position, then the new position here the electron is set. Okay, but in that time this place also creates the vacancy of electron. So these types of vacancy is called hole. So here we do not see any hole on that semiconductor, but there is a presence of hole, because when the electron passes from one position to the another position, then it creates some vacancy of the electron. So hole is not a positive charge or positive charged ion, it is only the vacancy or leakage position of the electron. So the flow of hole and electron are opposite to each other. If the electron is flowing in that position, then hole is flowing in that position. So the opposition of there is the opposition of flowing of hole and electron. So here only we see there is a extra number of electron, because all the electrons are set, but there is a extra number of electron which is coming from this pentavalent impure atom or antimony. So in that time we can say charge carrier have two types. One is majority charge carrier, another is our minority charge carrier. So what is the majority charge carrier? The amount of charge carrier is high in the majority charge carrier. So here you can see the amount of electron is high, because we get the extra electron from this antimony. So because of this extra electron, we can say the electron is our majority charge carrier of p-type semiconductor, but hole is our minority charge carrier. Why hole is minority charge carrier? Because there is a presence only a small amount of presence of hole, there is a no vast amount of presence of hole, because you can see there is a most vast amount of electron are set up, but not same as the hole is set up on those surface, on this surface. That's why the hole is minority charge carrier, minority charge carrier of n-type semiconductor. So here is the picture of n-type semiconductor. You can see there are actually another types of thing which I want to share you. This is donator. Okay, donating ion, or you can say this donor ion. So donor ion. So what is donor ion? This is not same as our electron or hole. Donor ion is our impure material. When I add some antimony, then it creates the free electron, and it serves some free electron or supplies some free electron on n-type semiconductor. When we apply this antimony or arsenic or any pentavalent atom, then the free electron is flowing from this antimony to the another atom. So we can say this: the antimony gives us or supplies some electron, extra electron. So it is actually one kind of donor, because donor can donate something. So this antimony or arsenic, when we apply this on a pure semiconductor, it donates us only one electron. So the donor ion is nothing but our antimony or arsenic or any pentavalent impure atom which have only 5 electrons on its outer shell. So here antimony or arsenic is our donor ion, but this donor ion is not same as our electron or hole. But when this donor ion serves or supplies some electron to the atom, then it creates some positive charge, because there is a leakage of electron and it also donates some electron. That's why it is going to be a positive charge, because in the first time or initial time, antimony or arsenic have only 5 electrons on its outer shell, but when it supplies one electron or give one electron or donate one electron to hold the semiconductor, then it is going to be a positive charge. So donor ion is nothing but one kind of positive charge. Okay, so here is actually our real picture of p-type semiconductor. You can see there are some positive charge that I have shown there, and this positive charge is around the circular shape. Okay, so this positive charge is nothing but our donor ion charge. Okay, so this indicates actually the antimony or arsenic, and there are several numbers of antimony and arsenic that I apply on that semiconductor, because when you make any n-type semiconductor, you do not use only one atom of semiconductor or impure material. So you have to use more than one impure material. So here are the number of antimony or arsenic materials, and this positive charge is coming from that antimony or arsenic. So those are our donor ion. So this is our donor ion. Okay, the second thing our is electron, which is majority charge carrier. So this negative sign is indicates our electron. And the last thing is our hole. So hole is this, and the number of hole is very much little on an n-type semiconductor. So this is all about the n-type semiconductor. And another important thing is, if you use only pure semiconductor, but you do not get the good conductive material. When you add some pentavalent impure atom, then the conductivity of pure semiconductor will increase. So these types of n-type semiconductor is very much useful on electronics. If you want to make diodes, if you want to make transistor, field effect transistor, or any amplifier, then you have to use this n-type semiconductor as well as p-type semiconductor, because the conductivity of n-type or p-type semiconductivity is high than pure semiconductor. So this is all about our n-type semiconductor. And one thing that I want to share with you, the people who are watching this video, please like, subscribe and press the bell icon of our YouTube channel. And also the people who are watching this video, please share this hashtag Crash School and post it on your public post of Facebook, Instagram or LinkedIn or Twitter. And also the people who are working as an engineer and also studying engineering subject, then please visit our official website, which is thecrashschool.com. Here you will find the topic which is about engineering subject. So please visit our website and find out the option which is about engineering, and also subscribe our YouTube channel and post hashtag Crash School on your social media.